Carbon cycle is a biochemical cycle in which carbon is exchanged between the four spheres of the Earth: atmosphere, lithosphere, hydrosphere, and biosphere. Autotrophs convert carbon dioxide into carbohydrates and other carbon compounds. Autotrophs are organisms that are able to produce their own food. They convert inorganic carbon dioxide into organic compounds, carbohydrates, lipids, and proteins. All of these through photosynthesis. The organisms that cannot synthesize their own organic molecules are called heterotrophs. They have to obtain their carbon compounds by feeding. Carbon dioxide is produced by respiration and diffuses out of organisms into water or the atmosphere. Cell respiration is the process in which organisms produce chemical energy. Cell respiration breaks down organic molecules and produces carbon dioxide as a byproduct. Carbon dioxide diffuses from the atmosphere or water into autotrophs. As autotrophs use carbon dioxide for photosynthesis, the concentration of CO2 in organisms must be low, and the concentration of CO2 in the atmosphere must be higher. This drop of the concentration ensures that the carbon dioxide will passively diffuse into the autotroph's organism as needed. In aquatic autotrophs, CO2 diffuses directly into the organism. However, in terrestrial plants, the diffusion occurs at the stomata.
Carbon dioxide is dissolved and some of it will remain as dissolved gas. These remains will combine with water to form carbonic acid will dissociate to form hydrogen carbonate ions. This change releases hydrogen ions, creating a change in the pH when carbon dioxide is dissolved in water. Autotrophs absorb both dissolved carbon dioxide and hydrogen carbonate ions and use them to produce organic compounds. When hydrogen carbonate ions come into contact with rocks and sediments on the ocean floor, they acquire metal ions. This results into the formation of calcium carbonates and then limestone. Living animals can combine hydrogen carbonates ions with carbon calcium, forming calcium carbonate. This calcium carbonate forms the hardened exoskeleton of coral, as well as forming the main component of mollusca shells. When the organism dies and settles to the seafloor, these hard components may become fossilized in the limestone. Methanogens are archaea microorganisms that produce methane as a metabolic byproduct in anaerobic conditions. Methanogens may be found in wetlands, for example swamp and marshes, marine sediments as in the mud of lake beds, digestive tract of ruminant animals, for example cows, sheep, and goats. When methane is released into the atmosphere, it persists just for 12 years. It naturally oxidizes, forming carbon dioxide and water. For this reason, methane levels are not so high on the atmosphere, although its production is.
It forms when organic matter is not fully decomposed because of acidic and/or anaerobic conditions in waterlogged soils. The partial decomposition. Soils have bacteria, fungi, and saprotrophic that decompose dead organisms and return the nutrients to the soil, and these continue in the cycle. This process requires oxygen, since when there is not enough soil and oxygen, they don't decompose completely. It is normal that in waterlogged regions, lack of oxygenated air spaces in the soil and therefore pose anaerobic conditions. Fossilized organic matter is the decomposition of organic matter from past geological eras. For a better explanation, living things are made up of chemical compounds, and most of them are the organic compounds, like carbon, oxygen, and hydrogen. As it is known, living things die: humans, animals, and plants. And when living things die, they decompose in the soil. So the accumulation of sediments become fuel, such as oil, coal, and gas.
Carbon cycle is a